بسم الله الرحمن الرحيم. صباح الخير جميعا. Mr. Robert Ayan, the deputy of Her Royal Highness Princess Sumaya bint Al Hassan, the patron of this event. Ladies and gentlemen, good morning. I would like to start by a short story of three men waiting their fate of death. And according to the custom, each one of them were given the final wish before they execute them. So basically, the first one said, I want a special type of meat so that I would enjoy the last meal of my life. While the second one was interested in delivering a 10-minute speech in innovation. But instantly, the third one jumped right after that and said, please execute me before the second one did his 10-minute speech in innovation. I hope this will not be the situation at your end, because speaking about innovation sometimes leads to boring lecturing style presentations. So I would go into what I believe about innovation and what we work at the Queen Rani Center for Entrepreneurship and what we develop in terms of programs and activities to support the creation of innovation-friendly environment. So I would say we all know that there has been plenty of speeches about innovation in the last few years in different parts of the world. Many of them consider innovation as a way to lead to more technology, R&D, and the new products and services. Well, actually that's not what I want to talk about today, because we believe innovation is not a product and innovation is not just technology. Moreover, innovation is not merely a concept. For us, innovation is a sustainable process. Let me repeat that again, because that's what I want to emphasize on this opening. Innovation is a sustainable process that we should adopt everywhere, at our nurseries, schools, colleges, research centers, NGOs, and businesses. As a community and as a country, we need to support sustainable process that transform challenges into competitive advantages. We need to foster an environment that encourages innovation and productivity. We need to be globally engaged in order to allow our children and younger generation to solve nation's most pressing problems through innovation. Mr. Robert Ayan, distinguished guests, our interest at the Queen Rani Center for Entrepreneurship in promoting systematic innovation did not start by coincidence, but as a result of deep thinking about how can we create startups that has a solid competitive advantage. According to international research done at the MIT Sloan School of Management, the most dominant competitive advantages in the business world during the last century was price. Price was the most dominant competitive advantage during the last century. And at the second part of last century, which is the 20th century, it moved to become quality as the most dominant competitive advantage for businesses. And now in the 21st century, it's now become innovation as the most dominant competitive advantage in different types and different scales of companies in the private sector. Yes, innovation considered as the primary competitive advantage that helps startups to go in line with the giants and even beat them with very much. Colleague Hussein Natshe, Ghadir Bawab, Najib Jarrar, Muhammad Shaheen, Muhammad Kilani, Ruba Abu Shashiye, and Evelyn, and everyone who really helped a lot day and night to make this event happen. And I would like, as a result of this short opening, to really wish you a very interesting, innovative day full of innovative interaction with our distinguished speakers. Thank you so much.
Now I would like to start by presenting the keynote speaker, the co-founder of the European TRIZ Association and the owner of ICG, training and consulting based in Netherlands. He is also the co-founder of Invention Machine Laboratories, currently known as Invention Machine Corporation in Boston, and which is regarded today as the world-leading company that supports early stages of innovation. Please welcome Mr. Valeri Souchkov.
So, good morning, ladies and gentlemen. My name is Valeri Souchkov, and I'm very happy to see you here in this room. And probably, as you've noticed from the program of this event, that it's not the only talk I'm going to give you right now in the morning, but I also will make two presentations during the day. So, my keynote talk, the first keynote talk, is called TRIZ-based systematic innovation. And in this talk, I'm going to talk about, in very general, of course, why is it difficult to innovate? What is innovation, first of all? And why we cannot innovate as we have used to innovate. Then I will introduce you what TRIZ is. Probably some of you already heard this word, but I know that many people have very vague idea about what TRIZ is. Then I will show you how TRIZ works, how it helps to solve problems, where to use TRIZ, where it's used around the world, and finally, we go with summary. As I was already presented, just a few highlights from my biography. I started my journey to innovation back in 1989, where we founded Invention Machine Laboratories in Minsk, Belarus. And then in 1993, we moved it to Boston, Massachusetts. So I'm not just a user of TRIZ, I'm not just an innovator, but I'm also a developer. I'm participating quite a lot in developing new tools for innovation which support early stages of innovation. I also train a lot. I train about 4,000 people, and also help companies, businesses, organizations to come up with innovative ideas and innovative solutions. Also teach at University of Twente in the Netherlands and Rotterdam School of Management. So that's a small list of companies I worked with. I worked with around 160 companies in total in 32 countries. So I would like you to answer me. Have you ever heard about TRIZ before? Do you know what it is? Those who did, please raise your hands. Okay, so at least we have some people here who heard about it. But by now, about 150 books were published in 10 languages, and new books emerge every year. So I know that there are whole countries which never heard this word. But basically, this word was never heard, I would say, before 1993, 1995, outside the former Soviet Union, where it was created. But now you see, look at this slide. The innovation leader of Intel Corporation, Amir Rogel, at TRIZCon 2008 at Kent State University said that TRIZ is Intel's innovation platform of the 21st century. So when I show the slide, that people are very confused. What's going on? Intel says it's their innovation platform, and we never heard about it. We don't know what it is. So in this talk, I'm going to show you what it is, so at least you have a general picture of what it is and how it can be used. So let's start with a simple question. Why it's difficult to innovate? So, but before we go to that, we have a look what is innovation. You know, usually I don't talk about what is innovation. To me, it's very clear. But traveling among different cultures, among different countries, I'm traveling a lot, I found that the word innovation is being understood very differently in different countries. For instance, in a country where I'm living and where my offices right now are in the Netherlands, Innovation is understood in a strictly business sense. What is innovation? Innovation is something new which you bring to the market, you implement it, and you make money on it. That's what we call innovation. If I'm talking about, let's say, Russia, they more understand innovation as a bright, great idea, which then you can patent. And, well, this idea becomes available via licensing and other activities. So that's how they understand innovation. Some people mess up innovation and invention. So to make it very clear, let's define it. Innovation is a successfully implemented invention. If we are talking about commercial aspects, we will be talking about that innovation is an invention which you brought to the market and which gives you revenues and is profitable. And it can be anything. It can be technical product, it can be social innovation, it can be medical innovation, like new medicine and so on. That's what we call innovation. In social sense, there might be new initiatives and new innovative policies which are brought to the world by governments. Okay, they don't give money. We are not talking about money, but in a way they help people, they help citizens, they help countries to move ahead. We can call it also innovation. So basically, any process of innovation consists of three distinct phases. First of all, it's the ideation phase. What is ideation phase? Ideation is a phase at which you generate a breakthrough idea. An idea that no one has invented before you. You are the first one. Once you generated this idea, it's not enough. The idea might be great, but nobody needs this idea. Nobody is going to pay this idea, and so on. So, first of all, you need to make this idea attractive. You have to check if this idea really is needed and design it to make a commercial product or a value proposition on the basis of this idea. But to have idea, so let's say after ideation phase, you might have a great idea of a new patent, and you can apply for a patent and obtain this patent. But patent is only a result of this stage. Then you have to prove that it works, then you have to implement it. You know, today we estimate that only about 20% of whole patent collections are in use. So each 4 or 5 patents are basically useless. For two reasons. Either they simply don't work, because when you apply for a patent, it's not necessary to prove that your idea or concept works. And second, well, you might get a patent, but a value of your patent is not recognized neither by companies who are going to produce something based on this patent, nor society, nor market. It's very often happens. That's why a number of patents, one of the metrics of innovation, which you have to use today, it's actually a very confusing metric. I would say that it's not about quantity, it's about quality. So, but okay, once we have a patent, we already know how to design and implement. We can use quite formal methods for that. But what do we do at the first stage? Where do we produce ideas? We produce ideas as responses. We produce ideas as a response to challenges, to needs, to demands, and so on. There are about 10 different triggers which trigger us for innovation. One of the triggers, for instance, is competition. It's a major driving force of innovation, basically in the developed world. Competition. We permanently, continuously need to innovate today. Because without it, we can't ensure the stability and continuity of any business organization. So, the way we did generation of ideas was always very poorly supported. As I said, what happens when it comes to innovation? How do we create new ideas? How do we respond to new market challenges? We simply do it by trials and errors, by blind guessing. Ideas are coming out of the blue. Well, let's have a look at a very simple thing. You have a beamer here in this room. Right. We have light in this room. Light. Right. So, I want to make a next invention. I want to invent a beamer which produces a perfect picture. We can see it very, very well with a very high luminosity, brightness, amount of light, but at the same time, I don't want to switch off lights in this room. How do we do that? Where do we look? Do we go to scientists, asking them to develop a more bright lamp? Or maybe we can develop some totally new principle? Or maybe we just have to get rid of a beamer and put here a huge plasma or LCD panel? So you see, we don't have a systematic approach. We simply start blindly guessing. Don't you feel that there is something wrong about it and how we do that? Industrial Research Institute in Washington, D.C. made quite a large study on about 10,000 companies, mostly big companies. And they found that to successfully implement one project, innovative project, we need, in general, on average, to generate from 3,000 to 5,000 raw ideas. Which means that only that out of these 5,000 ideas, 100 ideas will result in small projects. Out of these 100 ideas, 10 ideas will result in large projects. And out of these 10 projects, only one project will be successful. As a result, 94.6% of innovative projects never reach return of investment. That's what's going on. Can we afford to waste so much time and resources today? Definitely not. We can't work anymore with trials and errors. Nikola Tesla, one of the greatest inventors of the 20th century, said, if Edison had a needle to find in a haystack, he would proceed at once with the diligence of the bee to examine straw after straw until he found the object of his research. I was sorry witness of such doings, knowing that a little theory and calculation would have saved him 90% of his labor. All right. Okay. But I need to... It's done? Right. But okay. So, Nikola Tesla is one of the greatest inventive minds of the 20th century, 19th and 20th century. But not too many people know about him. So, anyway, it's not about number of ideas. We can produce thousands of ideas. And, but does number of ideas matter? If all these ideas look like this, do we like these ideas? It's actually a Swiss knife. Would you like to have this Swiss knife in your pocket? Definitely not. So we can all produce all this huge number of ideas, but it's not about quality. Oops, sorry. It's all about quantity. It's all about quality. It's not about quantity. But how to ensure that we produce the best idea? For many years, we thought that invention is a result of random, chaotic, creative thinking. You know, if someone tells you the word inventor, what immediately comes to our mind? Some crazy guy with some crazy hair, you know, wearing some crazy T-shirt in broken jeans, you know, barefoot usually. That's what we think about inventors. But all psychologists for 100 years tried to identify what makes people creative and how to put this creativity to the use so it becomes useful. So even today, when we are asked, can creativity be studied? The answer, no. It's something which brought to us. We are born with, well, it's true. We all are born creative. Everyone is creative. And everyone has the capability to create a great invention. I've been busy with that for 20 years, and I know that for sure. But it's like, imagine, you don't know mathematics. You never studied mathematics. And someone tells you, could you please divide 1 million by 376? Wow. What are you going to do? You wouldn't do it because you don't know mathematics. But if you know how to make operation of division, it's very simple. Any kid at school can do that. The same with creativity. Because we don't know the rules, because we don't know the way to do that, it doesn't mean that we cannot produce creative ideas. Yes, we can. So why we can't produce innovative ideas quickly and very much, and by demand? For a very simple reason. One of the reasons, the biggest reasons, is psychological inertia, mental inertia. Mental inertia means that our minds are blocked with known concepts, stereotypes, known solutions. When I said, okay, I'm making a presentation in this room, what kind of, how do we see the slides of my presentation? We know two solutions. One solution will be to display the slides with a beamer. Another solution will be to have an overhead projector. And maybe the third solution will be to put a plasma screen. Now, I'm telling you, I don't like neither of these solutions. Please, propose me something totally new, something radically new. You see, it's very difficult. Why? Because when we stand in the middle and we need to find a new idea, we need to have a search space. So we are standing here and start generating ideas. One idea, second idea, third idea, and so on. The more difficult problem is the bigger the search space is. So we've got to kiss a lot of frogs before we find our princess. But ideas which solve our problem, ideas which really great, ideas which provide maximum value versus lowest costs are in a small segment of this huge space. And it's never guaranteed that by trials and errors you go this way. No. The chances are you'll be walking here for a long time. And like Confucius said, it is very difficult to find a black cat in a dark room, especially when the cat is not there. You know, I've conducted a lot of creative sessions and innovative sessions at different corporations. And I'm talking about really world-leading innovative corporations. And they do exactly the same. So there are two ways to cope with this problem. Either to use random methods, which expand our search space, which help us with brainstorm, or to use systematic methods. But systematic methods have not existed. We don't know about them. We don't believe that creativity and innovation can be made systematic. So morphological metrics, TRIZ, are the answers to these problems. And they help us directly. While starting to solve a problem or starting to solve a new idea, to search for a new idea, we are directly guided towards these strong solutions. Solutions which, well, will be successful, we would say. So, systematic approach versus trials and errors. Why systematic approach? Henry Halschuer, a founder of TRIZ, what TRIZ means I will tell you a few seconds later, said, do you really believe, I'm often asked, do you really believe that anyone can be taught creativity? Yes, every engineer might and can learn how to solve tasks which we regard as creative. Can someone learn to move at the speed of 50 kilometers per hour? No, we know that a man has a barrier. We cannot run more than, I don't know, 12 kilometers per hour. That is impossible. It's a barrier. But if we use a horse or a car, we can go 50, 60, 70 kilometers per hour. So, can everybody learn to dig faster than the best shovel worker? Yes, if we replace a shovel with an excavator. TRIZ provides an engineer with such an excavator. So what is TRIZ? TRIZ stands for a theory of inventive problem solving. Oh, sorry, solving inventive problems. Basically, it's not a very good correction from Russian. Original Russian title sounds like Теория решения изобретательских задач. TRIZ. That's why abbreviation TRIZ is used. TRIZ. So, well, better translation would be in English, theory of solving inventive tasks. Because usually when we say the word problem, we assume something very harmful, something negative, which is not true. Task is more broad. For instance, I would like to increase a performance of this conference. We all used to know to the fact how these conferences are organized. Right? People write papers, make presentations, they come all together, and everybody makes a speech, every speaker presents his or her content. And then in the breaks, we are going outside, have some tea, coffee, and network with each other. That's a standard model. We all used to that, right? But my question is, can you increase the performance of this event by radical innovation? What do you think? Give me an idea. How? Well, recently we proposed one type of conference that every speaker distributes his video of his talk pre-recorded. So when people come to the conference, when here in the room, they don't listen to my presentation. They already watched it on a DVD or when they are in the flight or they're in the home when they have. But when we sit here, when we all are here, we talk. So you already watched my presentation. So we come here just to discuss with me the content of my presentation. And then we can spend much more time for networking. Because one of the biggest reasons today people come for conferences are networking, right? So again, you see, we spend a lot of time by listening to my presentation. Let's say every speaker gives a presentation for 20 minutes. Why don't you have, before the conference, a DVD with, let's say, if we have 50 speakers, 50 talks? You know, many conferences have parallel tracks. And it's very, very, sometimes, I want to be at 2 sessions at once. I can't. So I miss a talk. So you get the idea? So I wouldn't say that it's a great idea. No, it's just a different model of organizing conferences, where stress is put not on presentation, where stress is put on discussions and networking. Okay. TRIZ and systematic innovation are a set of methods and techniques which help solving non-ordinary problems and produce innovative ideas. So what is non-ordinary problem? A problem which no one has solved before. We have 2 types of problems. A problem which was solved, we call them typical problems, and problems which no one has solved before. Well, usually in technology, if you solve a problem that no one has solved before, you obtain invention. You make invention. TRIZ. So what did Altshuler decided to do? Basically, he wanted to understand how engineers come up with best ideas. Well, what psychologists do in this case? They sit together with an engineer and look what he does. Maybe he straightens his hair. Maybe he wears yellow shoes. And then they write a book. If you want to come up with a great idea, you have to sit, you have to scratch your head, and you must be in yellow shoes. Then the chances are you will generate a great idea. Well, it seems funny, but it's true. I've read, I don't know, maybe more than a couple of 100 books on that issue. It's written by serious academicians, actually. Okay, Altshuler decided to go a different way. He put a personality of an inventor aside and said, I'm looking at the results. Together with his friend, they took 400,000 patents from patent collections, 400,000, different, totally different, and analyzed them. And you know what? They discovered that a number of general patterns of creative solutions is very small, which comply with majority of inventions. Basically, they identified 40 such patterns. Today we know about 100. They discovered that technology is not evolving chaotically. It's evolving according to certain rules and trends in a systematic way. It doesn't matter, you are talking about medical devices, you are talking about space stations, or you are talking about microelectronics. The trends of evolution are actually almost identical in each area. They extracted basic principles behind the processes of technical and business creativity, and what's more important, that made them repeatable. That's why today TRIZ is a collection of techniques which you can simply start, apply, use. Okay, at one end you have a problem, on the other hand you have a solution. What we call most ideal, the best solution. And in between you have a process. So what makes TRIZ and systematic innovation different from other approaches to enhancing creativity. First of all, they have analytical logic and problem-solving techniques, but also they have knowledge base of solution patterns. I will give you an example in a minute, so you will see that. What are analytical logic and problem-solving techniques? Okay, again, I said maybe, look at this beamer. A beamer is here, and I would say it produces some noise. In our nature of a human being is once we have a problem, okay, a beamer is noisy. So what do? We immediately jump to solutions. We say, okay, a beamer is noisy. So we have to solve this problem. So what do? Let's put a pillow around the beamer. Yes, to isolate from the noise. Right? No, of course not. I say, okay, what noise is there? Cooling fan. Simply remove cooling fan from the beamer. Great, nice idea. Let's make beamers without cooling fans, right? No. Yes, Doc. What's going on? Okay, what do we do next? And I say it different. Once you have a problem, we must analyze it. We must decompose it into sub-problems. And finally, we have to formulate our problem correctly. Do we have a tool for that? No. Well, sorry, I'm wrong. Yes, we do. But this tool was developed within TRIZ. A very nice tool, or we have even several tools. When we have a problem, or we have a certain product, system, and say, okay, we want to innovate, let's go ahead very systematically, top-down, logically understand what causes a problem, what are roots of problems, what are contradictions. It's one very important thing in TRIZ. And then how we can solve them. And we have tools how to deal with that model, problem models, contradictions, etc. Another layer of TRIZ, foundation, is a theory of man-made systems evolution and a new paradigm of inventive thinking. You will see an example in a second. And finally, we have creative imagination development. You know, we might study sciences for 20 years, obtain 3 PhD degrees, whatever. But once Einstein said, there is nothing more important in our thinking than imagination. Another phrase of him, imagination is much more important than logic. Basically, you know that Einstein did not understand his theory of relativity. A mathematical apparatus for it was developed by Poincaré. And Einstein actually told it many times that I absolutely don't understand what's inside. But was it an obstacle for him to create this theory of relativity? No. He came up with a concept, and others filled it with a mathematical content, which Einstein didn't understand. But it was not necessary for him to understand. Imagination is very, very important. And without imagination, we might be as smart as we want, but the chances that we will produce great ideas, breakthrough ideas, are not that high. Basically, the best degree of imagination is possessed by kids. Kids are extremely creative. Kids don't go for compromises. Kids find breakthrough solutions. But while we grow, 5 years old, 6 years old, we go to basic school, we learn rules, we go to school, we learn more rules, we go to university, we learn even more rules. And we are afraid to break this rule or this rule or this rule or this rule. And this all contributes to increasing our psychological inertia. So TRIZ was also designed to help these barriers, to break these patterns, mental patterns, with introducing general principle of innovation and creative imagination development. So, everything's fine? Okay. Now, instead of chaotic guessing, we have a process, 6-step process. Once we have any challenge, someone told us we must innovate, improve this beamer, or reduce the noise, or increase the performance of the conference, or increase a sales performance of a business organization, we have over 6 steps. First, we analyze what's going on. We map the existing situation, problems, and decompose them. Then we select key issue or a problem. Then we apply special TRIZ techniques and tools to generate new ideas. And then we apply special techniques for building ideas portfolio and scoring and selection of best candidates, so-called ideas landscape. So that's the process we follow, whatever task we do. Well, one thing which I want to say is that TRIZ, modern TRIZ, it has been evolving for 50 years, and it's quite complex. There are different TRIZ schools, and TRIZ has different tools inside. An official TRIZ has around 27 tools. But you see, we have different tools. If we want to understand, decompose, and structure problem situations, if we want to innovatively improve existing products and services, if we want to generate, develop new ideas of innovative solutions, if we want to develop future generation of product, process, service, because there is a difference. One difference is, okay, there is a beamer, and I want to reduce its noise. And a second task is, I want to develop a new generation of a beamer. We can predict anticipatory failures, which are going to happen. We have tools to understand market evolution and finding, discovering problems. And we have tools for creative imagination development and selection, evaluation, and assessment. So you see, I still have approximately 20 minutes, right? Yes? Yeah, okay. So, and to explain each this technique, I need probably 1 hour. So you see, I don't have 27 hours, I only have 20 minutes. So I will show you just one of them. One of them which helps to solve problems. It's one of the oldest but most widely used TRIZ technique. So, as I said, instead of directly jumping from a problem to a solution, how many trials and errors I have to do? Very simple answer. Edison, when he was looking for a material for a lamp, electrical bulb, his lab made a test of 10,000 materials. So they made 10,000 trials. But it was in 1890-something. At that time, people have plenty of time. You know, today we don't have time. You know, LG Electronics, for instance, today renews their mobile phones line. How often? Tell me. 6 months. Oh, it was last year. Each 6 months. Today, they renew their mobile phone lines every month. Every month, they have new models coming in. So if you don't innovate, how do you cope with this situation? So, instead of solving a specific problem and jumping directly to specific solutions, I do the following. After I analyze the problem, I find what the problem model, what the specific problem is, and I build an abstract problem according to certain rules. And then I apply a TRIZ solution pattern or inventive principle, and I generate abstract solution. An abstract solution is a kind of a recommendation of guidelines. What shall I do to obtain the best solution? These TRIZ patterns and inventive principles are extracted and accumulated experience of the best generations of inventors. Of the best ideas these generations of inventors had ever produced. So, and then I have guidelines, I follow these guidelines, and I obtain specific solutions. So, often problems are difficult to solve because of contradicting demands which have to be fulfilled. Now, I'm telling you about the most important concept of TRIZ. It's called contradiction. Contradiction is a conflict of demands. That's what makes us non-creative. A simple, very simple example. Again, look at the beamer. We are sitting here. You're watching my presentation. You see, okay, the screen looks nice, but it can be better, much better, right? So the contrast ratio could be like 100,000 to 1, and here we have maybe 500 to 1. So it's not very, I would say it could be much better. All right. So to solve this problem, what we can do? We can switch off the light, right? Yes? Yes. Then, of course, the brightness light interferes with the beaming going out of the beamer, and then we have much brighter picture. But what happens if we switch off the light? You see that many people do handwritings. They do some notes. We also are looking at each other, right? We want to see each other. To sit in complete darkness, it's not a good idea. So, my question is, how much light should be in the room? Ambient light, I mean. Sorry? Of course, if we want to see the screen well, there should be no light at all, right? Switch off the light. But then we feel uncomfortable. We can't write down the notes. We can't see each other. So to fulfill this condition, how much light shall we have in the room? A lot of light, right? A standard solution is to find an optimum. To find a certain value of a parameter, which is luminosity in this case, which will satisfy both conditions. Well, this is not innovation. This is optimization. Innovation comes when you resolve this contradiction, when you eliminate it, which means you see the screen very well, the picture is extremely bright and nice, and at the same time, you can do your hand notes. So please tell me a solution. And my problem formulation looks impossible. I want both a lot of light and no light at all at once. Is it possible? Yes? Or not? Okay, if you think yes, how? Change the screen. Remove the beamer. Make it a plasma screen. Okay. Any other ideas? Spotlight. There, great. So you see, what we can do here, we can separate conflicting demands in space. Actually, I don't need light here, ambient light. But for you to make handwritings, you might have light, spotlights. So you see, a contradiction which seemed to be impossible to solve, after a little bit of creative thinking, is solved. Let's have a look at the example. Another example. My friend was working at Samsung Electronics, Samsung Mechanical Division at that time, and they are still producing vacuum cleaning robots. I don't know, you know these robots probably. These are circular ones. You buy it, bring it at home, press a button, and it goes by itself, runs around the room and cleans the dust. Great. A market research showed that customers prefer circular-shaped robots. Absolutely fun. Okay, so Koreans started to produce circular ones. But circular ones had one problem. The circular one cannot do corners very well. It just doesn't go there. So what they proposed, to make a frontal part of the robot flexible from rubber. Yeah, so it walks to the corner, presses against it. Rubber is deformed, but it's shaped exactly as a corner. Great idea? Great. To us, it seems it's a beautiful idea which has no problems. Right? Right. But this is also a good illustration that we cannot foresee and predict all the factors. Why? Because when Koreans started to buy these robots, bring them to houses, and switch them on, the next thing happened. You know, it's very known that Koreans love dogs, right? But of course, it was long ago that they used to eat dogs, but now they really love dogs to have them at home, at their homes. And dogs immediately think, when you put this robot on the floor, they immediately think that you bought this robot as a new toy for the dog. So they start barking them, chasing them, chewing on them, and finally destroying the rubber completely. So now we have a contradiction between two demands. On one hand, this frontal part should be flexible. So the robot goes, presses against the corner, and the frontal part is shaped accordingly. But on the other hand, it should be rigid. So when a dog starts chewing at it, it's not destroyed. How to solve this contradiction? In TRIZ, we have a way to do it. I won't get into details. Altshuler designed a so-called matrix of contradictions. Once you know a type of a contradiction, you go to the matrix, You you identify your problem model, compare it with one in the matrix. So it's one part of contradiction here, another is here. And you have a cell with numbers. And these numbers correspond to so-called inventive principles. What are inventive principles? These are patterns of strong solutions, guidelines, how you can change your product or a system to obtain invention, to resolve a contradiction. Simple example. Well, I'm sorry, there is small font, but I wanted to copy it from original work of Altshuler. The principle number one is very universal principle. It's called segmentation. It says, divide your object into independent parts. So any object, which object is causing a problem? Frontal part. Okay. An example here, an air duct elbow. You know, big air pipe which goes for ventilation in buildings, etc. When you have this 90-degree turn, a lot of turbulence is happening there, which is not good, especially if the flow of air is strong. So what was proposed? To segment it, to make an air duct elbow from thin pipes. In these pipes, no turbulation happens. So the flow is not destroyed. So you see, we took a big pipe and segmented it to several smaller pipes.